Now we consider the inequality absolute value of 2x plus 3 less than or equal to 9. Now, if the absolute value of 2x plus 3 is less or equal to 9, well, that's satisfied as long as 2x plus 3 is less than 9, less than or equal to 9, and also greater than or equal to negative 9. Just as we've seen that the absolute value of x would be less than or equal to 4, provided x is less than or equal to 4 and greater than or equal to negative 4. So whatever's inside the absolute value here, if it's between negative 9 and 9, then the absolute value is less than 9. If it's equal to 9, then the absolute value is equal to 9. Okay, so we interpret this inequality as 2x plus 3 less than or equal to 9 and 2x plus 3 greater than or equal to negative 9. If this is true, then as long as this is also true, the absolute value of 2x plus 3 will be less than or equal to 9. You need to stop and think about that if necessary. And of course that then means that negative 9 is less than or equal to 2x plus 3, which in turn is less than or equal to 9. So we subtract 3 from both sides, and we get negative 9 less not from both sides, from all three expressions. We get negative 12 less than or equal to 2x less than or equal to 6. Divide both sides by 2. We get negative 6 less than or equal to x less than or equal to 3. This is the solution to this inequality. Of course, we can sketch a picture of that solution. It would just be the inclusive interval from negative 6 to 3. And I can probably make a small sketch. It's not a very good number, though. This thing kind of wobbled on me. But we have negative 6 and 3. We include the endpoints, and we shade the interval between. Okay. The next inequality is absolute value of 3 plus x greater than 4. Now, if the absolute value of something is greater than 4, that's satisfied as long as that something is bigger than 4 or less than negative 4. So we can break this into two statements, 3 plus x greater than 4 or 3 plus x less than negative 4. Again, either of these conditions assures that x is a solution to this inequality. Well, we easily solve this inequality. We get x greater than 1. We easily solve this when we get x less than negative 7. We could write this as the interval negative infinity, negative 7, union the interval 1, infinity. And I'll slip in a picture here. If this is 1 and this is negative 7, then the solution set, let me use a different color, is going to consist of everything up to negative 7 but not including, and everything to the right of 1 but not including 1. Now this anticipates something we're going to talk about very shortly. What number is in the middle of these of this missing interval here? Okay, what number is in the middle here between negative 7 and 1, halfway between negative 7 and 1? Well, you can use a formula or you can just reason it out. It's pretty easy to see that it's going to be 3. Okay, so these intervals are in a sense then centered at 3. Also, how far is it from 3 to 1? Well, this distance is 4. How far is it from 3 to negative 7? This distance is also 4. How does that relate to the inequality? And hang on a second. I said halfway between negative 7 and 1 is 3. It's negative 3. So, again, these intervals are in a sense then centered at negative 3, and they extend 4 units to the right and 4 units to the left of negative 3. Note that we have 3 plus x. This negative 3 here is related to this 3, and the distance 4 is related to the 4 here, in a way that we'll see shortly and in a way that you might well already understand.